Hi, it's time for another math easy solution. Trying to discuss further into partial fraction decomposition, and now look at for the case where we have repeating and non-linear factors in the denominator of the rational function we're decomposing. Basically, in my earlier videos, I covered general techniques for solving linear, non-linear, and repeating factors in the denominators of rational functions such as these. So we have this one here I covered, where at the denominator here we have, well, both of these are linear factors, right? And they're not repeating, so those are linear. Here we have linear, and we have a repeating factor right here, because we have x minus 1 to the power of 3, so this repeats 3 times. And yeah, and when here we also have, in this case, which I covered, this is a non-linear factor, because this is an x squared plus 3, so this x squared, you can't reduce it any more. And now we'll discuss basically if the denominator in the rational functions has basically any combination of these above of linear, nonlinear, and repeating factors. And if this case comes across, we can just simply combine all the techniques that we used to decompose them in my earlier videos. Yeah, so now let's take a look at an example that has a combination of all these. Basically, this example states decompose, but do not solve for the coefficients of the following rational functions. So we look at this one here, it's pretty complicated. X to the power 4 plus 3x minus 2, all divided by x squared plus 1 cubed, times by x minus 4 to the power of 2. Now in this case we have here, this is, well, non-linear right here, this x squared plus 1 linear, and it's also repeating, and it's a power of 3 right there, so it repeats 3 times. And now we have here, this is linear, and this is again repeating twice, so we have a combination of linear, non-linear, and they're all repeating. So we could just use the combination of the methods that we have that I showed in my earlier videos for each individual case. So this one here, we could write this as partial fractions like this, where if we look at this x squared plus 1 power of 3, you have to account for all the cases, as well as writing the denominator as a polynomial, or as a linear function in this case, because that's x squared. So we have an ax plus b right here. This is 4x squared plus 1. And now we have to, for this, account for the x squared plus 1 squared. So now we'll have a cx plus d. So we have to put a linear function, like I showed in my earlier videos, so make sure to watch that one on why we have to do this. And now we have an x squared plus 1 squared, and now for if we have e x plus f, this is for the last case in this one, x squared plus 1 power of 3. So because it's repeating, we have to account for any of the partial fractions where we add up the squares or the cubes, or without any squares or cubes, like this one. And now we have to add, now we have to account for this linear and repeating factor. So EF, and then we'll have a G over x minus 4. And now the last one is an H to account for the x minus 4 squared. X minus 4 squared. So this is all we're asked to do in this example. It's going to take a long time to basically solve for A, B, C, D, E, F, G, H. So this is it for now. So that is our answer right here. Anyways, that's all for today. Hopefully you learned from this. Just this quick example on on how we apply partial fraction decomposition for repeating and non-linear factors using the and if we have both terms inside the denominator of a rational function. Anyways, that's all for today. Hopefully you learned from this video, and like always, you can download these exact notes in the link below, and stay tuned for another math easy solution.